Hello and welcome back to Dr. T's Algebra 2. In the previous video, we introduced parabolas as a set of points equidistant from a focus and a directrix, and then also three different forms you might see algebraically to describe or to define a parabola. And so let's go back to the example I had, which was y equals x minus 5 quantity squared plus 2. We knew our vertex is 5, 2 because we are in vertex form, so it's quite easy to find a vertex. Now imagine if we wanted to find our directrix. Our directrix is a line, so it has to be defined as y equals. It's a horizontal line. So it's going to be a constant. So y is equal to, well, we know that when we have our parabola graphed out, in this case, our vertex is at 5, 2. We know that directrix is going to be somewhere underneath. It's going to be somewhere here. And we know our focus is going to be somewhere inside the parabola there. To find that, we're going to start with the k component, which is the y component of the vertex, and then we're going to subtract from that some constant. We're subtracting because it is below. I'm going to call it p. That's what those mathematicians call it. And then the focus inside the parabola, well, we know that's equidistant from the vertex. We know it's a point, so we're not going to have y equals. It's just going to be a point value. We know that the x value is on the same vertical line there. This is called the axis of symmetry. It's on that same vertical line as the vertex. And so our h, or our x value in the vertex, is going to stay the same for a point. That's the focus. But then it's got to be some measure above k, above our y value. It's going to be k plus that p. And again, we know that from the vertex to the focus, back down to the directrix, these are all the same distance. And so how do we find p? Well, luckily some mathematicians figured it out a while ago. Our p is equal to 1 over 4a. Now in this instance, our a would go here, but we don't have anything there. And when we don't see anything, we know that is actually 1. It's not 0. And so in this case, we know a is equal to 1. Well, now we have one equation and one variable unknown. So we can solve for p. P then is equal to 1 over 4 times 1, or 1 over 4. And so 1/4 in decimal then would be 0.025. Now we can work with our values of h and k, which we know are 5 and 2, and find both the directrix and the focus. So if y equals k minus p, then y equals 2 minus 0.25. And that's going to be our directrix. Y is equal to 1.75. And we know that for our focus, just call it big F, h is still equal to that same value from the original equation. But now we need to take k plus p, 2 plus 0.25, and so we get our focus at 5 and 2.25. So now every point on this parabola is equidistant from that focus to the directrix. All right, so now let's start with our vertex form. y is equal to x minus 5 squared plus, I said 2. That was our standard parabola that we're working with. And we know we can find the vertex here very simply, but let's say we want to know the y-intercept. Well, the easiest, simplest way of finding the y-intercept is to convert this to standard form. To convert to standard form, we have to expand. Our first step is going to be expand. And there are a number of different methods for expansion. But what we need to do is take x minus 5 and multiply it by itself, x minus 5. When I was in high school, we learned FOIL, which is first, outside, inside, last. First, outside, inside, last. Basically, this is distributive property, distribution. Each component of the first set of parentheses needs to be distributed to each component of the second set of parentheses. So the x is distributed to x, the x is distributed to 5, the negative 5 is distributed to x, and the negative 5 is distributed to negative 5. Now, some students also learn the box method, where we're going to put our two different sets of parentheses on these axes here, and then just multiply. We get x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is 25. And then we just add them all together. Some students also learn or respond better to the snowflake method, where we're going to put x minus 5. Here's our first parentheses. There's our second parentheses. Then we're going to put the sum of negative 5 and negative 5 here, which is negative 10. And we're going to put the product up here. Negative 5 times negative 5 is 25. And this is where your x is going to go. Any way you do it, as long as you get the same answer, that's the main idea. So we're going to get x squared minus 10x plus 25. That's our expanded form. Whether it's first inside, inside, last, FOIL, or the box method, or the snowflake method, doesn't matter to me. Shouldn't matter to your teacher. So we've got our expanded form here, and then we need to add to that 2 on the end. So our standard form equation is x squared minus 10x plus 27. And recall from the first video, this c value is the y-intercept. So we know the vertex from the vertex form. That's 5, 2. And then we can find up here somewhere, 0, 27 is our y-intercept. And if we wanted to check that, we can plug this into a table, x and y. If x is 0, then 0 minus 5 is negative 5. Negative 5 squared is 25. 25 plus 2 is 27. So that's how to start from a vertex form, get it into expanded form, and then find the y-intercept in standard form. Don't forget to add your constant onto the end here before you say that you found the y-intercept. This has been Dr. T's Algebra 2. In the next video, we'll move back and forth between the different forms of parabolas. Thank you.